Yes, Ashutosh. So, guys, um, am I audible? Am I audible and visible to you?
Yes, ma'am.
Yes,
Huh.
yes,
So,
ma'am.
let me introduce myself. My name is Malik Arslan Nisar, and I am a TA for this course. So, this is a tutorial class in which we will be discussing some problems related to the course content you have studied during the week. So, how many of you have watched all for 5 lectures which have been uploaded? People are still joining. So, have you gone through the lectures of this week?
Week one lecture I saw, ma'am.
Huh?
Week one.
Yeah, week one lectures. Have you watched them?
Uh, yes.
Okay, fine. So, let me share my screen. Hmm. So, is my screen visible to all of you?
Yes, ma'am.
Okay, fine. Yeah. So, let us start. Okay, people are still joining. uh, Guys, please join on time because like it will create disturbance in future classes. Since this is the first lecture, it is fine, but from next session try to join on time. It will save your and my time as well. So anyone wants to summarize the topics that have been covered during the week? Any volunteer? Anyone who wants to? Okay, so
Ma'am,
yeah.
ma'am. Okay. And first week, the 5 videos are loaded. First one is matrix operation and types of matrix.
Mm-hmm.
And then I think rank related topics in the second video. Third, determinant. And 4 and 5, vector spaces 1 and 2.
Okay, fine. So many of you would already be familiar with these topics, है ना? From class 12th itself, you have been studying matrices, what is the determinant of a matrix, what is the rank of a matrix, and then vector spaces, right? So I will try to solve 4 questions during this session, which will more or less cover all of the topics, correct? So let's start with question number one. Is my screen visible to all of you? What I'm writing?
This is it's visible.
Yeah. So consider the following statements. I want you all to take a pen and a copy because this is a maths class, so you know you'll only learn if you're solving on your own, right? So I want you guys to solve along with me. Then only this tutorial will make a sense. So consider the following statements. The product of two orthogonal matrices is also orthogonal. The second statement is the determinant of an orthogonal matrix is always 1. Can you people mute yourself because there's a lot of noise coming from your side? Yeah. The third statement is the null space of any orthogonal matrix is 0. Then the fourth statement is if A is an n cross n symmetric matrix, symmetric orthogonal matrix, then E square is equal to I. Which of the following is true? So, are you guys noting along with me?
Yes, ma'am.
Okay, fine. Have you noted it down? Guys, I want this to be an interactive session, so please respond when I'm asking anything so that I can continue further.
Yes, ma'am. Yes, ma'am.
Okay. So, if you look at this question, it's more or less based on orthogonal matrix, right? You can see all the four statements which you have to prove whether they are correct or not. They revolve around orthogonal matrices. So, would anyone of you want to say what an orthogonal matrix is? Anyone?
The inverse of a matrix is the transpose of its matrix.
The inverse of the matrix gives a transpose. It's correct, but it's a property. It's not the definition.
A matrix A transpose equal to I.
Yeah, that is again the same thing. A transpose equals I, which implies A transpose is equal to A inverse. And that is
A
a
inverse.
property. Correct. So look at my screen. I will first tell you what an orthogonal matrix is. Suppose Q is an orthogonal matrix which has column vectors say q1, q2 up to qn. Correct. These are the column vectors of a matrix, of this matrix, orthogonal matrix. So by definition, what we say that all these q's, all the column vectors, that is qi's, are unit vectors. Sorry. When all the column vectors of a matrix are unit vectors and are linearly independent among themselves, correct? They are unit vectors, they are linearly independent, and if you multiply any column vector with another column vector, say you multiply q1 with q2, or you multiply q1 with q3, or you multiply q2 with qn, in general, if you multiply any qi with any qj, it is going to give you a 0, and any qi when multiplied with itself, say q1 with itself, q2 with itself, it's going to give you a 1. Then this matrix is known a orthogonal matrix. Understood?
Yes.
Yeah. So this is the basic definition of an orthogonal matrix, and as you guys said that q into q transpose gives us I, which implies q transpose is equal to q inverse. It is a property of the orthogonal matrix. So now looking at the statement, what the statement,
Madam,
yeah,
sorry. What about unique vectors? QIs are unit vectors.
they are all unit vectors. It's like, suppose you have a column vector, okay? I am taking it as q1, so you can take it as q11, then here it is q21, q31, q41. So when you take their magnitude, that will be equal to 1. So that is a property. That is the unit vectors part. Okay, it's just a
Okay,
property of
fine.
orthogonal matrix that the columns are definitely going to be a unit vector. Understood?
Okay, ma'am. Thank you.
Yeah. So now moving to the first statement. So the product of two orthogonal matrices is also orthogonal. So what is your say on this? Is it true or is it false? You can
True.
put your answers in chat box also. That is fine.
Okay.
And you can say also.
One is right.
It is true, ma'am.
It is true. Okay, so can you prove that?
Yes.
Yeah, like you can just say a line or two, then I will show how to do it.
Actually, I used property A transpose equal to I. So two matrices I take A and B, A transpose equal to I, and B transpose equal to
Yeah,
I,
correct,
and
correct.
I try
Yeah,
to
yeah, you're
prove
doing the right thing. You're doing the right thing.
AB transpose equal AB the whole transpose equal to I. That I try to prove. That's it.
Yeah, that is how you're going to solve it. So I will show you here. Look at the solution, please. Now, the question is telling us that we have two orthogonal matrices Q1 and Q1 and Q2, and we have to prove that their product Q1 and Q2 is also orthogonal. So by definition, if Q1 is orthogonal, then Q1 into Q1 transpose is equal to I, correct? And Q2 into Q2 transpose is also equal to I, correct? Then we have to prove that Q1, Q2 is also orthogonal. That means if the matrix Q1 multiplied with Q2, if I take the transpose of it and multiply with itself, then it should give I, correct? यही मतलब है ना statement का, that Q1, Q2 is another matrix which I get by the multiplication of these two matrices. And if I multiply them with its transpose, it should also give me I. That is the purpose. So here you can see Q1, Q2, then Q1, Q2 transpose. You all people know that the transpose of AB is equal to B transpose A transpose, correct? So we can write it as Q transpose, Q2 transpose and Q1 transpose. Now look at here. Q2 into Q2 transpose. It is already given that Q2 is a orthogonal matrix. So Q2 into Q2 transpose is equal to I. So this gives us Q1 I, Q1 transpose. And then again, I multiplied with anything, it's simply the same matrix. Then Q1 into Q1 transpose, it is again equal to I. So we started with Q1, Q2 and multiplied it with its transpose and we got I. So since it satisfies the property, it is an orthogonal matrix as well. So the first point is correct. So every one of you understood this? You guys understood this or do I need to repeat anything? You people can tell me if I am going too
Understood.
far. Huh? Yeah, Kavita.
Yes, ma'am. Understood for me.
So you people can tell me if I am going too fast or too slow, so I can accordingly adjust my pace. So you people have noted this down. Should I move to the next part? And I want response from maximum of you.
Sure, sure.
Okay. So moving on to the second part. What the second part says us, the determinant of an orthogonal matrix is always 1. Correct. So anyone tried to solve this one?
I think it's wrong.
You think it's
It's
wrong. Anyone
yeah,
else
it's
who supports whether it's wrong or right?
Yes,
Yeah,
it's
so
wrong.
two people. So anyone else tried this except from Kavita and Uni? So, Oni,
Because
what should I pronounce it? Do you want to summarize how you did it, how you proved it's wrong?
Yeah, it's named as Undi.
Huh? Okay,
Undi,
it's
Undi.
Unni. Okay,
Okay.
so Unni, can you tell me how the second statement is wrong?
Um, uh, the A inverse is equal to A transpose. Therefore, A transpose is equal to I. Taking determinant on both sides, I get
Yeah.
uh, A determinant A into determinant A transpose is
Yes.
equal to 1.
Huh.
Since determinant A transpose is equal to determinant A, determinant A squared equal to 1, that should imply determinant A equal to plus or minus 1.
Yes. Kavita, you did it the same way.
I don't know, but my answer is the determinant of the orthogonal matrix is either plus or minus 1.
Sorry, you were not audible.
Determinant, determinant of orthogonal matrix is either 1 or minus 1. But
Yeah, but can
here,
you prove
this
that?
was always 1.
Yeah, but can you
Uh,
prove
I,
that?
I have an point logic only. A equal to A inverse. So the eigenvalues of A and A inverse are all reciprocal. Eigenvalue of A and it's reciprocal. It's the eigenvalue of A inverse. So the only possibility I take 1 minus 1.
No,
Logically I
the
select, but
logic
not it's
is
not
not
a
correct somehow because it's not definitely going to be the reciprocal, but the way Anni said, it's going to be that way only. So, you guys, if you have figured it out, then it's fine. If not, then look here.
okay.
See, you.
Yes.
Wait a second. Hmm. So, you people know that you all had studied determinants, right? Wait a second, my pen is not working. Yeah. So, hmm. So you all have studied determinants in probably the third lecture, and you know that determinant of the multiplication of two matrices. If I have two matrices A and B and I multiply and take their determinants, it will be equal to the individual multiplication of the determinants, correct? The determinant of AB is equal to determinant of A multiplied by determinant of B. Then there is another property that the determinant of A transpose is equal to determinant of A, correct? You all know what a transpose is. If I have a
Yes.
matrix with certain number of rows, then while taking transpose, I exchange the rows with columns, correct? So that is how we get the transpose. And meanwhile, the determinant remains preserved. So the determinant of A transpose will be the same as determinant of A. So using these properties, we are going to prove that determinant of an orthogonal matrix is always 1. Look here, if I have an orthogonal matrix Q, then Q, we know that Q into Q transpose is equal to I, correct? Therefore, determinant of Q into Q transpose will be equal to determinant of I, correct? You all know that, okay, from this property, determinant of Q into Q transpose will be equal to determinant of Q into determinant of Q transpose. And what is the determinant of I?
1.
1. Correct. The determinant of 1, I is 1. So look here, from this we know that, from this equation we know that A transpose का determinant A के determinant के बराबर होता है. So here also we can write determinant of Q into determinant of Q, correct? Is equal to 1. And यहाँ से we can write determinant of Q का square is equal to 1. And therefore determinant of Q is equal to under root of 1, which will give us plus and minus 1. So since the option is showing that determinant of an orthogonal matrix is always 1, that is not correct. It can be either +1 or it can be -1. So here I will tell you an additional thing, that when the determinant is +1, it is known as a rotation matrix. So many of you who would be doing PhD, they would be knowing what a rotation matrix is, correct? And if it's -1, it is a reflection matrix. You will be using these matrices in subjects such as robotics, etc. A simple example of a rotation matrix is of a 3x3 rotation matrix is simply sine theta, cos theta, 0, cos theta, minus sine theta, 0, 0, 0, 1. This is a rotation matrix. And simply a reflection matrix. In reflection matrix, we can form it arbitrarily, but the property is that the determinant is going to be -1. And what the reflection matrix does, if you have any number, it just reflects it, or any vector, it reflects it when it acts on that number. So the second statement has also been proven that it is not correct. Now moving to the, do you guys need time to write this down, or have you copied it already? Should I move further, or you
Copy.
need to copy it?
Yes,
Okay.
ma'am.
Yeah, I'll give you a minute. You note it down, then we'll move further. So should I move further?
Yes, ma'am.
Okay. If you guys need to write anything down, you can stop me. So the third statement. Anyone wants to read the third statement? Radha? Or maybe Kiran? Anyone? Aniket? Ronak, you?
The null space of any orthogonal matrix is 0.
Okay, the null space of any orthogonal matrix is 0. So do you guys understand what this statement means? Because in order to prove whether this is right or wrong, you should first understand the statement, right? So tell me what this statement means. Anyone? Okay. So do you guys know what a null space is? Anyone?
Null space, set of all x such that ax is equal to 0.
Yeah, correct. So what a null space is defined as set of vectors such that ax is equal to 0. And it means the null space of vector A is the set X. This is what the definition of null space is. You guys know that A is a matrix, right? Or a linear transformation. A is called a matrix or a linear transformation. What does that mean? That the matrix A operates, linear transformation is an operation, or you can say it's a mapping, that it operates on a set X, on a set of vectors to give another set of vectors. ठीक है? What, like we usually write ax is equal to b and say it's a system of equations. In actual, that means that there is a linear transformation linear transformation A, which acts on a vector, on a set of vectors x to give b. Here x is the pre-image and B is the image. In class 12th, you would have read that there are functions, and then the functions are mappings which map one number to another number. Similarly, matrix is also a mapping which takes vectors from one set and transforms it into the another set. That is why it's called a transformation, also linear transformation. So here, null space means that when the linear transformation acts on a certain vectors and only transforms it to zero. Like there is this matrix A and I give it a particular set of vectors, and when it acts on this particular set of vectors, it always maps it to zero. Like we will get zero, you put x1, you put x2, you give x3 to it, it will always map it to zero. So that means this is called the null space of this matrix. Understood what a null space is? Any doubt in this?
Yeah, ma'am.
So the question here is that null space of any orthogonal matrix is zero. We have to prove that for null space, the matrix this x1, x2, x3, it's nothing but zero. Like x1, x2, x3, they won't have any other value, they have zero. So we have to prove it. So for the proof, if anyone has done it, he can share. Otherwise,
Yeah.
I will move ahead.
Yeah, ma'am.
So you did it?
Yeah.
Cool. You want to tell us how you did it?
Yeah, ma'am. Suppose I take an arbitrary element f x belongs to null space of A,
Mm-hmm.
then ax is equal to 0 by definition.
Mm-hmm.
Then I multiply by A transpose on left to the both sides of equation. Then I get A transpose AX is equal to uh, A transpose 0. That is equal to 0. That is identity of x into identity into x is equal to 0. That is x is equal to 0.
Okay, I'm not sure about this method because uh, we can discuss this after class, like whether the procedure you're following it's correct or not. But I will show you a more generalized way of doing the same thing. Fine. Now
Okay.
look at my screen. By definition, we know Q is an orthogonal matrix. So it will be composed of Q1, Q2, so, and Qn column vectors, correct?
Yeah, yeah. All are event matrix.
Yeah. All are
Vectors.
linearly independent,
Independent.
correct? By definition, we have to find qx equal to 0. We have to find a vector x such that qx is equal to 0, correct? So we can write it as q1, q2, q3, so, and qn, and multiply it with a vector x1, x2, so, and xn, and it should give us 0, correct? Now look here. When we multiply this thing, it will give us q1 x1 plus q2 x2 plus q3 x3 plus so qn xn, correct? Am I doing this right?
Yes, yes.
Yeah. So since we know that q1, q2, q3 are linearly independent, do you guys first understand what is linear dependence and independence? Any one of you who wants to say
Yeah.
what a linearly independent vector is? Like
Um,
linearly independent vectors, what linearly independent vectors are?
Linear combination of those vectors should equal to 0 implies all consciousness be 0.
No,
Is
linearly independent. You are giving me the
yeah.
definition of dependent.
No, no. Suppose V1, V2, etc. Vn are vectors.
Uh-huh.
Suppose it's linear combination alpha 1, V1, etc. Alpha and Vn equal to 0. Then all the constants alpha is from field equal to 0.
Yes. What it means linear independence, that see,
It has a trivial solution that all scalars all are zero. That is linearly independent.
yeah. So for the essence of that
Trivial
thing, I'll
solution.
make you understand. See, if we you all are familiar with the coordinate system, like, right? It is simple. We have I cap, then we have j cap, then we have k cap, correct? And these three are linearly independent, right? Because we know that if I add 3i then minus 3j, it's not going to be 0, correct? 3k plus minus 3i, it's not going to be 0, correct? Why? Because any combination of these vectors will not give 0, because they are linearly independent. Like j is independent of I is independent of k. But if I take a vector 3i, then I subtract 3i from it, it will give us 0. Why? Because they are linearly dependent. They are on the same axis. For making the understanding simple, I am putting it this way, that you can simply understand that these three vectors are linearly independent, so their combination will not give as such 0. Because like if you add any xi plus yj plus zk, you know that if the sum is 0, then x has to be 0, y has to be 0, z has to be 0, correct? You understand this thing, because आप लोग कोई और नंबर लोगे, यहाँ पे 3 भी लोगे, यहाँ -3 लोगे, यहाँ 0 लोगे, वो नहीं होगा, because 3 and -3 they will not cancel each other. Why? Because they are not linearly dependent, they are linearly independent. So if a set of linearly independent vectors is 0, it means each one of them is 0. Like x भी अपनी जगह 0 होगा, y भी 0 होगा, z भी 0 होगा, तब जाके ये 0 होगा. तो सिमिलरली अगर हमें पहले से पता है कि Q1, Q2, Q3, Qn सारे लीनियरली इंडिपेंडेंट है आपस में, है ना? वो तो डेफिनेशन ही है हमारे ऑर्थोगोनल होने की. सो इफ दे आर लीनियरली इंडिपेंडेंट, देन their any combination will only give 0 when x1 is equal to x2 is equal to x3, so on xn is equal to 0, correct? Understood?
Yes.
हाँ. So that is how we prove it. This was just for your reference. This is not part of the solution. ठीक है? तो let me erase this. Meanwhile, you can note down other things. हाँ. So अगर x1, x2, x3, xn सारे 0 हैं, तो इसका क्या मतलब होता है? What does it mean? It means the set x1, x2, x3, xn जो भी हमें चाहिए था, it is equal to 0, करेक्ट? सारे ही इसके एलिमेंट 0 हैं, तो इसको 0 के बराबर लिख सकते हैं. एंड दैट इज व्हाट द क्वेश्चन वाज आस्किंग अस. सी, द नल स्पेस ऑफ एनी ऑर्थोगोनल मैट्रिक्स इज 0. यानी इफ देयर इज अ नल स्पेस फॉर एनी ऑर्थोगोनल मैट्रिक्स, it is going to be 0. Like all these elements are going to be 0. So understood this thing?
Yes.
हाँ. Do you want to note it down या note कर लिया पहले?
Note it down.
Noted, ma'am.
Okay, understood as well ना? See, this is a live tutorial session, तो ये आप लोगों के understanding के लिए, because for the rest of the week you people are just watching the lectures, right? There is no interaction between you and the instructor. So today is something that you can interact with your fellows also, like your fellow mates. कल को you guys have to appear in the exam also, so it's better that you interact in this session as much as possible. ठीक है. So now going on to the fourth statement. Anyone wants to read it out? Kiran, Radha and Aniket or Shreya, any one of you? आप लोगों में से कोई नोट डाउन करना चाहता है, लाइक रीड आउट करना चाहता है फोर्थ पार्ट? Okay, fine. Anyone on his own choice?
If A is an n/n symmetric square matrix, orthogonal matrix, then A square equal to I.
Okay. So fourth statement हमारा कहता है that if A is an n cross n symmetric, it is symmetric as well as orthogonal, right? Symmetric and orthogonal matrix. Then we have to prove that A square is equal to I. फाइन. आप लोगों को पता है, यू गाइज आर कंफर्टेबल विथ हिंदी ना?
Yeah, ma'am. I'm from Kerala.
Yes, ma'am.
So
Yes, ma'am.
still
I
you are
can understand.
comfortable with Hindi, right?
No,
Yes,
no,
ma'am.
no, ma'am.
Okay,
I'm
okay,
from Kerala.
you're not comfortable.
Yeah, no, no. I'm from
Okay,
Kerala.
okay,
I can understand English.
okay. Okay, it's fine, Aniket, but I hope you all are writing down the solutions. You are trying to understand them. And meanwhile, if you have a doubt, you can stop me. Lekin if it's regarding to the question or to the concept, because that will only waste the time of the class. But you can stop me in between if you have any doubt understanding the solution. So now we have given that A is an n cross n symmetric and orthogonal matrix. You know what the definition of symmetric matrix is? Anyone?
Yes, ma'am.
Yeah.
A equal to A transpose.
A is equal to A transpose. Correct. This is the definition of symmetric matrix. And what is the definition of orthogonal matrix? Like the property that A into A transpose is equal to I. Correct. From these two, we can substitute A transpose with A. है ना? Because in question it says it is symmetric also, it is orthogonal also. So if it is symmetric, that means A transpose should be equal to A. तो यहाँ हम A को मल्टीप्लाई कर रहे थे A ट्रांसपोज के साथ. वी कैन रिप्लेस A ट्रांसपोज विद A. सो दिस वन वाज सिंपल. A स्क्वायर इज इक्वल टू I. करेक्ट. प्रूव हो गया यहीं पे. एनी डाउट इन दिस वन? दिस वन वाज वेरी सिंपल.
No, ma'am.
No, ma'am.
Yes.
Fine. So you can note it down. Then we will move to next question. So I think next question is on rank. So
Okay.
you all would be knowing till now what rank of a matrix is and how to calculate it. Correct?
Yes, ma'am.
कितने लोगों को रैंक निकालना आता है? यू कैन रेज योर हैंड्स ऑल्सो. कितने लोगों को रैंक निकालना आता है? हाउ मेनी ऑफ यू नो हाउ टू कैलकुलेट रैंक? और देन आई विल सिंपली गिव यू अ क्वेश्चन. Otherwise, I will show you how to calculate it first. Then another problem you will do on your own. Okay.
Ma'am, that's how to calculate it.
Okay, you want to see how a rank is calculated, right?
Yes, ma'am.
Okay. What is a rank? आप लोगों में से कोई बता सकता है? Since you have attended the lectures, just give me the definition of rank. Like how do you define rank?
What of the highest subsquare matrix was determined is known, sir.
You are not clearly audible to me.
Order of the subsquare matrix was determined is known, sir.
Okay. Anyone else?
Highest order.
Highest order.
Order
you
of
mean by
non-vanishing subsquare matrix. Highest order of non-vanishing subsquare matrix.
Okay, highest order of non-vanishing subsquare matrix. ठीक है.
Order of
Whatever you guys
minor
said,
of-
I would try to put it in simple words. Rank of a matrix, as I told you, that you all know that a matrix A is composed of certain rows. Correct? There will be R1, R2, R3. है ना? By R1, R2, R3, I mean like it will be something like A11, A12, A13, then A21, A22, A23, and so on. It will go up to ANN. Correct? This will be a matrix. So what the rank is? Rank means the number of linearly independent rows or columns. Either one of them. The number of linearly independent. Since I already told you what linear independence and dependence is, the number of linearly independent, you will just have to stick to this definition, that number of linearly independent rows in a matrix. Number of linearly independent rows or columns in a matrix is known as the rank of the matrix. इसका क्या मतलब होता है? I'll make you understand with a simple example. ठीक है? Say I am writing 1, 2, 3, then I'll write 2, 4, 6, then I will write 1, 0, 1. See, if you will look clearly at rows 1 and 2, can you make some conclusion from row 1 and row 2?
Dependent.
Dependent, correct?
Because if you multiply 1 by 2,
Yeah.
you get the second.
Exactly. See, 1, 2 and 3. The row 2 is nothing but just multiplication of row 1 with 2. When you multiply row 1 with 2, it will give it 1 into 2 is equal to 2, 2 into 2, 4, 3 into 2, 6. So it means that this row is completely dependent on first row. So this one is linearly dependent. It's not independent. So what we remain with 1, 2, 3 and 1, 0, 1. Is there any combination जिससे आप 1, 2, 3 को 1, 0, 1 बना सकते हो? Like anything you can multiply or you can add to make 1, 0, 1? No, there is no combination. 1, 2, 3 is independent of 1, 0, 1. So the rank of this matrix will be 2. Simple as that. So this is what a rank is. Now, this was a simple case. By visual inspection, you got what the rank is. But there will be cases when there will be big, like huge matrices, and it will not be clearly visible which column is dependent on which column or which row is dependent on which row, correct? That time you will need a proper method to solve the rank of the matrix. And that method is known as row reduced echelon form. Is it visible clearly? Row reduced echelon form gives you the rank of the matrix. So you would have studied it during the week's content, correct? आपको पढ़ाया होगा while calculating the rank. Did the professor mention row reduced echelon form?
Yes, ma'am.
Yes,
Yes,
ma'am.
yes.
Yes, yes.
So any of you would like to describe what a row reduced echelon form is?
It should be echelon form.
Yeah, what is that form?
Leading entry, leading non-zero number of zeros preceding a non-zero
See, let
entry
me
in
tell
a
you.
row. It should be increasing.
Let me tell you what a row reduced echelon form is. It says all the leading entry in each non-zero row is 1. Like for this row, leading entry is 1 here. So it should be 1. Like जो पहली entry आती है किसी भी row में, that should be 1, others have to be 0. Like if this is the leading entry, these have to be 0. So. So this is known as a row reduced echelon form. In the method of solving, like for solving the rank of a matrix, to get the rank of a matrix, what we do, we try to reduce the matrix to its row reduced echelon form, and during the procedure we get clearly how many rows are linearly independent, and that is how we calculate the calculate the rank of the matrix. I will take an example here, उससे आप लोगों को ज़्यादा समझ में आएगा. I want you guys to solve along with me. आप लोग calculations करिए, take your calculators or anything so that you can solve along with me. So look at this matrix here. This is a 5 cross 4 matrix, correct? Sorry, 4 cross 5. So this is a 4 cross 5 matrix, and have you noted it? Please respond.
Yes, ma'am. Noted.
Okay.
Yes,
So
ma'am.
yeah, जब हमें सॉल्व करना होता है फॉर calculating the rank of a matrix, or when we try to get the row reduced echelon form, what we try to do is we try to make these entries 1 first. Since it's not a square matrix, अगर आपके पास एक square matrix होता है, the diagonal entries you try to make them 1, and rest non-diagonal entries you try to make them 0. While doing this thing, you will get the row reduced echelon form, because all the leading entries will be 1 and not other entries will be 0. So this is the basic procedure, ठीक है? There are other ways also of doing it, but I will tell you the standard procedure. So आप वैसे करेंगे तो you will never face difficulties. The method might be wrong, like long, but it will always be correct. So first we will focus on making this 3 equal to 1. So how can we make it 1? Anyone? You guys are familiar with matrix transformations, correct? Row transformations आते हैं ना सबको? Because only then you will understand this thing. कितने लोग हैं जिनको रो ट्रांसफॉर्मेशन के बारे में नहीं पता? Like all of you know what is a row transformation, correct?
Yes, ma'am.
Okay. So tell me, what should I do to make this 3 equal to 1?
Interchanging first and third row.
Yeah, that we can do, but since I told you कि एक standard procedure है, I will follow that. What if यहाँ पे 1 की जगह 2 होता, like it would have been 3 0 2 4? How would you make this 3 a 1?
Dividing the first row by 3.
Correct. What you will do, you will divide first row by 3. So the first row transformation is that I will change r1 into r1 divided by 3. So please solve along with me, guys. कर लिए आप इस चीज को कर लीजिए, and tell me what the matrix is coming out to be.
1, 2 by 3, minus 1 by 3, 4 by 3, 1.
1 by 3, correct? Not
1 by 3.
Yeah. And the other will remain unchanged, correct? Are rest of the people following it?
Yes, ma'am.
ऐसा तो नहीं है ना that I am going too fast or you people are not understanding it?
No, understanding it.
Fine, na? I hope that is the case with everyone. Kiran, are you understanding it? Because you said
Yes.
that you want to see how to calculate the rank. So you are getting it right?
Yes, ma'am.
Okay. So, wait a second. So, now since you made this equal to 1, the second purpose is going to be that in this column, you have to make all other entries equal to 0. ठीक है? As I said, leading entry should be 1, others should be 0. So starting from first column, you can see that leading entries का 1 है, others have to be 0. So how will you make others 0? This one is already 0. How do you make these two 0? Anyone?
R3 replaced by R3 minus R1.
R3 minus R1. ठीक है. Here what we do, simple procedure आप याद रखोगे. This is the basic, that since you made this one 1, ठीक है, other entries आपके जो भी होते हैं, whatever the rest of the entries are, you can simply multiply, like you can do third row minus simply first row, and you can do fourth row minus 4 times of first row. If there is another number 7, you can do that row minus 7 times of first row. The purpose of making this entry 1 was that other entries जो भी होंगे, you will subtract that much times first row so that you get 0 here. Understood? ये point सबको समझ में आया? ये point सबको समझ में आया? Anyone who did not understand what I said? So I will take it as a yes. C. करने से आपको ज़्यादा समझ में आएगा. Now R3 में हम simply कर सकते हैं R3 minus R1. Correct? And R4 के लिए हम कर सकते हैं R4 is equal to R4 minus 4 times R1. Correct? R4 में से 4 times R1 माइनस करेंगे तो ये 0 हो जाएगा. R3 में से R1 माइनस करेंगे तो ये 0 हो जाएगा. बट ये लगेगा पूरे रो पे. So can you tell me what the matrix becomes after this? And this time I want the answer from any other person. Maybe Vivek or Kiran. Any one of you? Tell me what the matrix is becoming. This one will remain unchanged because we are not doing any operation on this. R2 is also remaining unchanged. We are not doing any operation on this. What does R3 become? Kiran, Aniket, Vivek, anyone? Radha? Or Kavita or Anni, any one of you? You guys are solving it or not? Because I want you all to solve it with me. That is the purpose of this class. If you are sitting it, then you have other option also. That is watching the video lecture which you have done throughout the week. The purpose is that you solve along with me. If I make any mistake, you correct me. So what does the third row become here?
0 minus 11 by 3
Okay, 0 minus 11 by 3
minus 2 by 3
minus 2 by 3
minus 1 by 3. Sorry. Minus 1 by 3
1 by 3.
I think no, it's not like that. It is becoming minus 11 by 3. It's 1 by 3 here, right?
Yes, sir.
yes
Yeah.
no, sorry 1 by 3 minus 2.
So here it is becoming 1 by 3.
No, sir.
This one is minus 1 by 3. This one is 5 by 3.
5 by 3.
And what is the fourth row? It's 0 minus 17 by 3, 7 by 3, minus 13 by 3, and minus 7 by 3. Is this fine? All of you have gotten the same?
Yes, ma'am.
Yes ma'am.
Okay. Now, so first column is sorted. We have this the way we wanted it to be. Now for the second column, see, we have a 1 here. So this is the leading. For this row, this is already 0. So this is the leading entry. So leading entry had to be 1. Correct? You have to remember these 2 points. The leading entry should be 1 and others should be 0. So here the leading entry is 1. Others have to be, in this column, others have to be 0. Correct? So how you will make the others 0? It's simply the same procedure you have to follow. यहाँ पे 1 है. What you can do is R1 minus 2 by 3 times of R2. Then R3 plus 11 by 3 times of R2. Then R4 plus 17 by 3 times of R2. Because this is minus 17 by 3, you multiply this with 17 by 3 and add them, it will be a 0. Understanding? See, I will write them down for your understanding. Then you follow. R3 plus 11 times 11 by 3 times R2. R4 is R4 plus 17 by 3 R2. And then R1 will be R1 minus 2 by 3 R2. Perform these operations on the above matrix and tell me what you are getting. Are you guys doing it? Are you guys doing it? What is the result
Yes,
of,
ma'am.
yeah, what is the result? See, firstly, रो टू विल रिमेन अनचेंज बिकॉज इसमें हमने R2 पे कोई भी वो नहीं करा है ना, सिर्फ R3, R4 और R1 को चेंज किया है. सो रो टू विल रिमेन सेम एज इट इज. टेल मी व्हाट R1 विल बी. What is R1? R1 is going to be 1, 0, 1 by 3, 0, minus 1. Is it correct? You are getting the same?
For third row,
Yeah. R3.
0, 0,
Yes, 0, 0.
minus 10 by 3,
Yes,
21 by 3,
correct.
27 by 3.
Yes. So, कोई और बोलना चाहेगा what R4 becomes other than Kavita because she is solving others. This one is going to be 0, 0, minus 10 by 3, 21 by 3, 27 by 3. This is also coming out to be same. So I'm speeding it up because we don't have much time. And for your reference, you can do it at home also. If it's taking you time here, do solve it on your own also. Correct. Now see, second row is also, yeah, second row is also sorted now. Now moving on to the third column. Correct. What we will do in the third column again, we will see. Here I will give you a tip. Since we know R3 and R4 here are exactly same. You guys can see it, right?
Yes.
So one of them is linearly dependent on other. So you can simply make that row 0. Like you can say R4 is equal to R4 minus R3. You will simply make this one 0 here only. So it will give you something like 1, 0, 1 by 3, 0, minus 1, 0, 1, minus 1, 2, 2, 0, 0, minus 10 by 3, 21 by 3, 27 by 3, and this row will be completely 0. Correct? Now, what we can do is, after this diagonal, there is this diagonal element, then there is this diagonal element. So we will try to make it 1. Correct? That is our focus. We have to make them 1, then remaining we try to make 0. Again, I am repeating so that you memorize this thing. You don't forget it. That's why I am repeating it. So we will try to make this 1. So for making this 1, we will divide this row by minus 10 by 3. So what we will do, R3 is equal to R3 divided by minus 10 by 3. Correct? So perform the calculations fast and let me know what you are getting. This will be 0, this will be 0, this will be 1. Correct? And if you are calculating this correct, it will be minus 21 by 10, and this one will be equal to again minus 27 by 10. Correct? It's very simple. You can see it. Then last row is already 0. Correct? You noted till here? Should I move further?
Yes, ma'am.
Okay. So now look at this row. Here you can see these three rows are linearly independent. How you get this? Don't focus on these elements, just focus here. If you focus on these three rows, here we have a 1, remaining 2 are 0. Here we have a 1, remaining 2 are 0. Here we have a 1 and no, wait a second. There we don't have a 0 and here we don't have a 0. So we will have to make these also 0 first. Okay. These two we will have to make 0 because 1, 1 and 1. These two we will have to make 0. So we will do further 2 row transformation. What they are going to be? We have R1 will be simply R1 minus 1 by 3 of R3, correct? R1 is 1 by 3 and R3 is 1. So subtracting minus times 1 by 3 of this from this will make it 0, correct? You can check it on your own also. So this will make this 0 and for making this one 0, we will simply add these two, correct? So here we will do R2 is equal to R2 plus R3. So this will also become 0 and it will reduce to this form. Take note here, this remains, this will be 0, this will be 0. Performing this thing here, it will give us 7 by 10. You can verify on your own because maybe I am making some mistakes while solving. You can correct it. This one will be minus 1 by 2. Can you confirm if I am doing it correct or not? So this is the matrix we are getting. How many of you got the same matrix? How many of you got the same matrix? Okay. So this is the matrix we will be getting. Now focus here. See, here we have a 1, others are 0. Here we have a 1, others are 0. Here we have a 1, others are 0. So from there only you can like figure out that no combination of this row and this row will give each other. Like this and this you cannot add to get this because here already we have a 1, here we have a 0. If you multiply anything, if you say twice of first row and thrice of third row should give a second row, it will not give. Why? Because twice of this row will be 2, 0, 0 and thrice of this row will be 0, 0 and 3. So this 0 and this 0 will not add up to give this one. So these three are linearly independent and this one is already 0. We figured out earlier that it was dependent. So the rank of this matrix is going to be 3. Correct? So that is how you calculate rank. This is the RREF of this matrix, row reduced echelon form, RREF. So whenever you follow this standard procedure, you will get the rank of the matrix. There are other ways also, but this is the standard. So did you guys understand this? Is it clear now, Kiran? Oh, Kiran has left already. So others? Yeah, Kavita. You have raised your hand. Do you have a doubt?
That is previously I raised as you asked. It is here, yes.
Okay. So you understood, correct?
Yes, ma'am.
Okay. So rest also other people understood
Yes,
and
ma'am.
noted this down as well.
Yes, yes.
Okay. You guys can respond via chat or if you have, you can respond through mic or through chat also so that I can understand that you guys are following me. Correct? Now, should I give you a small problem so that you can solve it on your own just for your understanding? Should we do that? Let This is a classwork question. You guys have to do it. Let A is equal to 1, 3, 7, 9, 1, 2, 3, 4, 2, 5, 10, 13. So find rank of A transpose. This is A. You have to take A transpose, then find its rank. Do you want to take it as a homework question or you want to solve it here?
Ma'am, can you please show how to solve this question? I could not join in the initial steps of the previous question. If it's not uh, difficult for you.
Are you guys trying it?
Yes, ma'am.
Yeah, Anni, you have raised your hand. Is there any doubt?
Ma'am,
Are you guys trying it? Because I have been speaking from past 1 hour, so I want you guys to solve it
ma'am, is rank of A equal to rank
for
of A
five
transpose?
5 minutes. I'm giving you. Then we will discuss it.
Ma'am, rank of A transpose and rank of A are same or not? Hello, ma'am.
Shall we discuss the answer?
Yes, ma'am.
Answer,
Hello.
madam.
Hello, ma'am. Hello, Kavita, ma'am. I'm audible.
Ah, yes, sir.
Ma'am, is rank of A equal to rank of A transpose?
Uh,
How many of you got the right answer?
I
I mean,
think
how many
so.
of you arrived at any answer?
Actually, for this question, rank of A transfers both are same.
Hello?
Rank of A equal to rank of A. Hello, ma'am. I'm
You
audible.
guys are not audible. I think there is a problem with my speakers. Okay.
Me, sir, actually, for this question, rank is 2.
There is some issue if you are speaking. Please just put it in chat box because I am not able to listen.
Kavita, ma'am, I got answer is 2.
Okay,
Is
can
it
you
right?
solve and show? Okay,
Yes,
fine.
yes. Yes, sir. For if you try directly for A
So,
or A transport,
since we have
for both the
already
things, the
done
rank.
it in this form, right? RREF form, this is the same thing. So, I will not just repeat it, but I will show you a short trick of doing it because it's the same. Like we did it for a 4 cross 5 matrix, it is a relatively simpler one. It's a 3 cross 4 matrix. Answer 2. Yes, Kavita, you are right. You have got it right. Any other people who got the answer? Ani, please put it in chat box. If you're speaking, I'm not able to listen to you. I think there is some issue with my speakers. You can just put it in the chat box. Yeah, 2 is the correct answer. So I'll not solve this again because it is simply what I did in the previous question. It's just simply that. If you have not, can you show the previous problem full steps just by scrolling it? Okay, fine. For your reference, if you have to take screenshots, I can show you. So this one is row reduced echelon form. Then there is this. After that, we are following the row transformations to get a leading unity, and then others is 0. These are the steps. You can take a snapshot if you have missed it, because repeating it will just waste the time of the class. So for your reference, if others also need to take the screenshot, you can take. Is it fine, Anjali? Okay, fine. Fine. So here you can simply see that if I am adding just by visual inspection, if I am adding first row with second, it's giving me third row, correct? You can just simply see it here. So it means one of these two you can take as linearly independent and other as dependent. So when you take, say I am taking this as linearly independent and this one is dependent, I can nullify it, I can make it a 0. Then this row and this row, they are linearly independent. 1, 2, 3, 5, 7, 10, 9, 13. These two rows are linearly independent. So I am getting the rank of A. Or for A transpose also, I will simply show you some steps. You can do it like this also. Since you have to calculate the rank of A transpose, you take its transpose first. Correct. Here, again following the same precision, we have a leading one. Now what we have to do? We have to make other elements 0. So for making this 0, what we will do? R2 will be 3 times R1 minus R2. Correct. Then I'm just speeding it up because it's the same as previous one. So you are supposed to do it on your own also. R3 is equal to 7 R1 minus R2. Then R4 is equal to simply 9 times R1 minus R4. Correct. This is R3 here, sorry. And what you get is a matrix like this.
0, -1, minus 4, 4, 5.
This is the matrix you will get from solving it. After that, what you can do is you can simply in R4 you can try to make it 1, and in R4 you can try to make it 1. R3 also you can try to make it 1. So R4 is 1 by 4 times of R4, and R5 you can simply do 1 by 5 times of R3 and R4. This is R3 and R4. The rank of the matrix and its transpose the same. I'm not sure about this, so I will not give you an answer. I think it should be same, but I will clear that in next session. Okay, I'll note it down for your reference. I think it should be same because the determinant is also not changing when you are taking the transpose. Yeah, actually it will remain same because in during the taking the transpose, you just interchange the rows with the columns. So the rank, we have two methods of calculating rank. Either you do row transformation or column transformation, and rank will be same. So I think rank of transpose is also going to be same, but again remind me next class, I will check it once again. So R3 and R4, what we get here is 1 1 2, because first row is unchanged, second is this remains unchanged, this one will be 1 1, here again it will become 0 1 1. So you can clearly see these two rows are again linearly independent, and these two are dependent, so the rank is going to be 2. Correct? Understood? You might have done it from another method. If you are getting 2, 2 is the correct answer. These two rows are dependent and the above two are linearly independent. You can see it's a 1, it's a 0, it's a 1 and 1, 2 and 1. So they are linearly independent. The remaining two, they are dependent. So copied this. My speakers are, I think there is some problem. You can respond in chat box, please. So have you noted the solution? Please try it on your own as well. Should I move to the next question? Please raise your hands for this. Okay. Now, moving on to the next question. Since we have covered the topics on operation of matrices, that was the first lecture that we have covered through first question. Then there was determinant and rank that we have covered in these two questions. Then comes vectors. Okay. So I will solve one question on vector space as well. Fine. And that will be the last question of this session. After that, we will join on next Friday. So look at the screen and tell me if the question is visible. Question number 5. So let M be the vector space of all 3 cross 3 matrices and let A is equal to 2 1 0 0 2 0 0 0 3. Fine. This is a matrix and there is a vector space M. Then which of the following subsets of M is not subspace of M? So here I will go option by option. Let me make you understand the question first. We have given a vector space M which consists of all 3 cross 3 matrix, and then we have been given an arbitrary 3 cross 3 matrix, that is A. Fine. And we have been given that 3 is the vector space of all 3 cross 3 matrix. Then which of the following subsets of M is not a subspace of M? So for this question, I want to know from you guys, what is the difference between a subset and a subspace? Any one of you? Anyone? In chat box.
Subspace of a vector space should satisfy. Ma'am, am I audible?
Can you guys try to speak as well? I need to check if my speakers are working. Anyone? Kavita? Or maybe Anni?
Hello, ma'am.
Kavita,
No,
hello.
I'm audible.
Okay, they are speaking. Okay, yeah, fine. My speakers are not working. I don't know why this issue arised in middle. Second. Yeah, now it's working. Fine, fine. Can you speak? Yeah,
Ma'am, I'm
Hello.
audible.
yeah, one by
Hello.
one.
Okay.
Yes, Kavita. So can you tell me
Uh,
what a subset is and what a subspace is? Difference.
Subset just contain the elements from M, but subspace it satisfies some conditions
Yeah,
that is closed and the elements if you take it from any elements from M, the addition also belongs to the same,
yeah.
and the scalar multiplication also belongs to the vector space M. So
Yes,
then
yes,
only you
yes.
can say it is a subspace.
Yeah, correct, correct, correct. So this has been taught in the weekly lectures, correct?
Yes.
Yeah. So as Kavita said, that is the correct definition. The difference between subset and subspace, I will just explain with a simple example. Let me take this, you know the number line, correct? We have 0, plus 1, plus 2, plus 3, then minus 1, minus 2, minus 3, correct? So for this collection, if I'm talking about a subset, if I take the numbers from 0, 1, 2, 3, this is going to be a subset, right? Because इसी का एक छोटा सा part है. It is a small part of this set only. 0, 1, 2, 3 and so. So this is a subset, but it is not a subspace. Why? Why it is not a subspace? Because for satisfying the condition of subspace, there are two conditions. The first condition is that if there are some elements in a subspace, then the like if there is a set M and there are some elements in that, then the subspace should also contain the same elements, or the scalar multiples of the elements should also be contained in that subset. What does that mean? It means suppose if I have x1, x2, x3 in a space, then lambda times x1, lambda times x2, or alpha times x3, they should also be contained in this set, then only it will be called subspace. I will make you understand this with an example, then you will understand clearly, but filhal I am just telling you the properties, that the scalar multiplication should remain conserved, and there the second is linear combination. Linear combination means that if there is an element x1 and an element x2 in the space, then their linear combination should also be in that space, like alpha x1 plus beta x2 should also be present there. If it is not present there, then it is not a subspace. From this example which I gave earlier, you can see that I told 0, 1, 2, 3 and minus 1, minus 2, minus 3. Let us call this a vector. For this, we have a subset 0, 1, 2, 3. Why is it not a subspace? Because if I multiply this with minus 1, so it will be 0, minus 1, minus 2, minus 3, right? This is a scalar multiple, minus 1, minus 2, minus 3. It is not contained in this set. So it is not a it is not a subspace. It is a subset, but it is not a subspace, because when I multiplied it with minus 1, it gave me 0, minus 1, minus 2, minus 3, which is not in this set. So it is not a subspace. It is a subset, but it is not a subspace. Is the difference clear? Or should I repeat? I hope it's clear with you guys. Can you just confirm? Okay, fine. So this is clear. Now, moving on to the question. What was the question? Yeah. Now we have been given a vector space M which contains 3 cross 3 matrices, and there is one arbitrary matrix we have given A. Now there will be certain statements which we have to prove whether the following are the subset of M or like the following subsets, there will be certain subsets given, and we have to check if they lie in the subspace of M. So give me a minute, I will write the first one. See, the first is X belongs to M. Okay, M is a this is a subset of it where XA is equal to AX. So can you guys first give it a minute and check on your own whether this subset lies like this is a subspace of M or not? I want you to try it out. We have a vector space M for which these are the following subsets. This is the first subset, correct? In which X like are the elements of this subset. They belong to this subset such that XA is equal to AX. And now we have to prove whether or not this subset is a subspace also. That is what we have to prove. It is given it is a subset, but we have to prove whether it is a subspace or not. What we will do, it is simple. We will just check the two properties, correct? That is the only thing we have. First, we will check whether the scalar multiplication is satisfied. And second, we will check whether the linear combination is satisfied. If those both properties are satisfied, then it is a subspace as well. Understanding? Are you guys understanding what I'm saying?
Yes, ma'am.
Okay. So you want to try it out or should I proceed with the solution? And first you write these 2 points. I'm not sure if you are familiar with this or not, but for your reference, you note them down. First, scalar multiplied to the vector should also lie in that subset for it to be called a subspace. These are two important points. You have to note them down. First is that a scalar multiplied to the vector should also lie in that subset for it to be a subspace. Correct. And the second one is linear combination. Very important property. That is, if x1 comma x2 belong to the subset, it implies and alpha x1 plus beta x2 also lie in that subset, it implies it is the subspace. Please note these 2 points. And meanwhile, I think there is some answer from Annie. It is a subspace. Yeah, it is a subspace. Can you confirm how you did it? You can turn on your mic and say. For the first question. You are correct, but you can just tell how you did it.
Then I'm audible.
Yeah, you are audible.
I take two elements x and y from M from the set X.
You're not audible.
I take alpha x plus beta y. Then forming this element a into alpha x plus beta y. Then multiply, that is we get a into alpha x plus a into beta y. Taking alpha and beta scalars outside, I get a
Yeah.
in alpha into ax plus beta into ay. But
Yes.
ax is equal to xa and ay equal to ya. Then I alpha into xa plus beta into ia, taking a common. Then alpha x plus beta y into a. Therefore, alpha x plus beta y belongs to Z.
Yeah. That is the correct procedure. If others have figured it out, that is also good. Otherwise, you can look at the board. See, let I have two elements, say x1 and x2. In, as Annie said, x and y, we can take x1 and x2. So we know that x1 into a is equal to ax1, correct? It has been given in the definition of the subset that xa is equal to ax. So that is why we are considering this thing. So x1a is also equal to ax1, and for any other element of that subset, say x2, x2a is also equal to ax2, correct? Now for their linear combination, what you can do, you can just add them simply, correct? What I will do is, firstly we know that if this element lies in the vector space and in the subset, and this element also lies in the subset, then their linear combination should also lie in the subset for it to be a subspace, correct? So for that we will check this thing only. If x1a lies in that subset and x2a lies in that subset, then alpha times x1a plus beta times x2a should also lie in that subset for it to be a subspace. So that is what we will do. We will take their addition. First we will write alpha x1 plus beta x2 into a, correct? It should also lie in this subset. So we can expand this. It is equal to alpha x1a plus beta x2a, correct? Here we can take alpha here, x1a from here can be written as ax1, correct? See here it is x1a, it can be replaced with ax1. Then beta, similarly x2a can be replaced with ax2, correct? Now alpha x1 on the LHS plus beta x2 into a is giving me what? Here we can simply take a out and write alpha x1 plus beta x2, correct? So this is holding. See, again this is some alpha x1 plus beta x2, call it x3, and this is also x3. So x3a is equal to ax3. So means if x1 is belonging to a from definition and x2 is belonging to, sorry, x1 is belonging to that subset which satisfies this equation, and x2 is also belonging to that subset which satisfies this condition, and its linear combination is also for satisfying this condition. What does it imply? That the subset is a subspace, right? Understood? Do you guys understand what I'm telling, or do you have a confusion in this? Otherwise I'll repeat it. All of you got it? You can raise hands also, or if you have a doubt I'll repeat it again. You want me to repeat it again?
No, ma'am.
Okay, anyone who wants to repeat it again? Fine. You don't want to. You understood the point, na? I will still say that x1 and x2, they were satisfying the condition. Then their linear combination should also satisfy this condition. It means it is a subspace. So the first point is correct, right? Now check for this one. Check for the second one. X belongs to M such that x plus a is equal to a plus x. See, this one is simple. You don't even have to prove it. You know that the property of addition, it will always be applicable. It is commutative. so it will always hold good. So this also is a subspace. Fine, understood? Yeah, this one is pretty simple because the commutative property holds. So this is a subspace, like this lies in the subspace. Now for the third part, check this one. X belongs to M such that trace of AX is equal to 0. X belongs to M such that trace of AX is equal to 0. Give it a minute, then we will discuss the solution. Did you guys write? See, look here. This one is also simple. The way we proved first one, yeah, it is a subspace. Correct, Kavita. You got it right. If anyone else has also got it right, then good. Otherwise, look at the solution now. So we will prove this also like the previous part, like the first part we did, correct? What we will take, see, we have given that trace of AX is equal to 0, right? It has been given in the question. So if I take x1 comma x2, it implies that trace of ax1 is equal to 0, trace of ax2 is equal to 0, such that this x1 and x2 belong to that subset. ठीक है? x1 and x2 are belonging to that subset, and then trace of ax1 is equal to 0 from the condition given in the question, and trace of ax2 is also equal to 0. Now what we have to see? We have to see for alpha x1 plus beta x2 into A, its trace, right? Its trace should also be 0. Then only we can say that yes, this subset is a subspace also. Understanding, na? ax1 is equal to 0, ax2 is equal, like trace of ax1 is equal to 0, trace of ax2 is equal to 0. Then if trace of A into alpha x1 plus beta x2 is equal to 0, then only we can say that yeah, this is a subspace. So for proving that, what we can do is, we know the trace of this thing, we can first simply multiply trace of A times alpha x1 plus A times beta x2. Correct? We can do this thing. Then we know that trace of A plus B, we can simply write it as trace of A alpha x1 then plus trace of A beta x2. Right? Here alpha is a scalar, beta is a scalar, we can simply take them out. So we can write alpha times trace of ax1 plus beta times trace of ax2, right? And from definition, trace of ax1 is equal to 0, trace of ax2 is equal to 0. So this trace of ax2 is equal to 0, this trace of ax2 is equal to 0. So we can say that yes, trace of A into alpha x1 plus beta x2 is also equal to 0. So since this condition is satisfying, this is a subspace of, this is not only a subset but a subspace of M. Understood? We can similarly prove the other property also, which we are not considering, that is the scalar multiplication, but I will show for your reference. Say A is something like A, B, C, D, correct? For your reference. Then what is the trace? Trace is simply A into D, correct? Sorry, A plus D. Make it clear. So trace of A is simply A plus D. Now for the scalar multiplication part, if lambda times A, we will see that will be equal to lambda A, lambda B, lambda C, lambda D, correct? And lambda times A is equal to, for this trace will be equal to lambda times, sorry, trace of lambda A will be equal to lambda times A plus D, correct? So see, this property also holds. So we can simply say, we can say by this property also, that if this is holding, it means that this is a subspace of M. So yeah, third one is also a subspace. So have you guys noted it down? Has everyone noted it down? See guys, if you are not able to solve them in the question, it is fine. It's completely fine. Many of you might be reading this for the first time, correct? Because some of you already introduced that you are in BSc first year or second year. So these things will be very new to you. So if you are not understanding in the class, it is completely fine. If you're not understanding, but yeah, if you're not able to solve it on your own, it is completely fine. You just have to keep practicing. What I write on the board, you just note it down. Try to solve it again at your own place. You will eventually be able to solve it. So if in class you are not able to solve it, that doesn't mean you are not getting the concept. You just try to understand what I am teaching. Then again at your own place, you will practice it 1 or 2 times. Then you will get the concepts clear. So it's fine if you're not understanding it. Like if you're not able to do it here, it's completely fine. But take the notes, and I will also upload them in a folder. They will be accessible to you. And I know I have a little bit of, my handwriting is not that good. From next time I'll try to write more clearly. So for now, let's move to the fourth part. For the fourth part, yeah, X belongs to M such that determinant of AX is equal to 0. Take a minute and try to solve it. Try to check if this is a subspace of it. The definition is given that the determinant of AX is equal to 0.
Not a subspace. No.
Not a subspace. How did you arrive at it?
I think sum of determinant of a sum is not equal to sum of the determinants.
Yeah, correct.
It's the same one.
Yeah. So since you all got it, the determinant of sum, the sum of the determinants is not going to be the same. It will not be preserved. So for this, you can take simply an example, because when you have to prove that something is wrong, you can just give one example. Here I am taking an example for your understanding. Let me take x1 is equal to 0, 1, 0. Since M is a set of 3 cross 3 matrices, now that is why I am taking it as 3 cross 3. Let x1 be equal to 0, 1, 0, 0, 0, 1, 0, 0, 0. Correct? Then, and x2 is equal to 0, 1, 0, 1, 0, 1, 1, 0, 1. This is my x2. Now, ax1 you can verify is equal to 0. ax2 you can verify is equal to 0. You can do it now also. Multiply a with x, then take the determinant. When you multiply two 3 cross 3 matrix, you will get another 3 cross 3 matrix. Then taking its determinant, you will see that it is going to be 0. I can do it for you also, but since there is not much time in the class, you can verify this on your own, or let me just do it. Multiply these two matrices and tell me what you are getting. All of you, please do it. First one is going to be 0. Second one is going to be 2. Third one is going to be 1. Then again, this is going to be 0. Second one is going to be 0. Third one is going to be 2. Correct? Then again, this one is going to be 0. This one is going to be 0. This one is going to be 0. Now taking its determinant. What will be the determinant? You can simply see one column is completely 0. So the determinant is going to be 0. Correct? Now similarly, you can verify for AX2. Correct? So A is 2, 1, 0, 0, 2, 0, 0, 0, 3. What is X2? Can you repeat what X2 is? Anyone? It's 0, 1, 0, 1, 0, 1, 1, 0, 1. This is my X2. So this is A, this is X2. So what is their multiplication? The multiplication is going to be 1, 2, 1. This one is going to be 2. This one is going to be 0. This one is going to be 2. No, this one is going to be 0. Now 2. Yeah. The third one is going to be 3. Then this is going to be 0. Then this is going to be 3. Correct. So what is the determinant? Calculate the determinant fast. It's simply 1 into 0 minus 2 into 6 minus 6, that is 0, then plus 1 into 0 minus 0, right? And this is again going to be 0. So AX1 is equal to 0 is satisfied, AX2 is equal to 0 is satisfied. What we have to check for? That A of x1 plus x2, sorry, A of, let me raise this, A of x1 plus x2, if you solve this, then taking the determinant whether it is 0 or not. Can you do it fast and tell me what you are getting the value of determinant? Please do it on your own end and tell me what you are getting the value. Anyone? Okay, you can take a minute more. Then tell me what you are getting the value of determinant. Kavita, Anni, anyone did? Ronak, Shreya. Are you guys trying it out? Anjali? Anyone? What is the value of this? Hmm? Are you guys at least trying it out? Yeah, Ronak, tell me what you got. Ronak, you raised your hand, right? What answer did you get? Anni has left the meeting. Others? Kavita? This is the last part, and after in a minute or two we will end this session. So did you guys get the answer? Fine.
24.
24 is the correct answer. Who got it? Radha. Yeah,
Yes.
correct. So when you calculate this thing, it's simple. What you have to do, x1 आपके पास दिया हुआ है, x2 आपके पास दिया हुआ है, दोनों को ऐड करोगे. ऐड करने के बाद एक और 3x3 मैट्रिक्स आएगी, उसको a के साथ मल्टीप्लाई करोगे, सिमिलरली जैसे मैंने ऊपर किया हुआ है. जब उसको मल्टीप्लाई करोगे और ऐसे डिटर्मिनेंट कैलकुलेट करोगे तो आपके पास वैल्यू 24 आएगी. आई विल नॉट डू दिस बिकॉज इट्स नथिंग, इट्स जस्ट कैलकुलेशन. करेक्ट. जैसे पीछे के दो कैलकुलेशन किए हैं, you have to do this similarly and you are getting the answer 24. So what does this imply कि ax1 तो हमारा ax1 का डिटर्मिनेंट तो 0 आया, ax2 का भी डिटर्मिनेंट 0 आया, लेकिन जब हमने इनका कॉम्बिनेशन लिया, लीनियर कॉम्बिनेशन x1 प्लस x2, उसको a के साथ मल्टीप्लाई करा, देन हमारे पास 0 नहीं आया. दैट मीन्स ये सेटिस्फाई नहीं कर रहा है वो प्रॉपर्टी को. सो दिस इज नॉट अ सबस्पेस. करेक्ट. जैसा कि अन्नी और कविता ने पहले ही बोला था कि दिस इज नॉट गोइंग टू बी द सबस्पेस बिकॉज डिटर्मिनेंट्स में ये होल्ड नहीं करता है. एंड दैट इज दिस इज जस्ट इट्स प्रूफ कि हाँ कैसे नहीं करता है. सो सबको समझ में आ गया आज का सेशन? लाइक डिड यू गाइज अंडरस्टैंड ऑल द क्वेश्चंस? Okay, fine. So you can practice it at your own place one more time. Then we will meet in the next session. If there are any feedbacks for me, you can definitely tell me because this tutorial session is going to be for you and it should be helpful for you only. So if there are any suggestions or feedbacks for the next class or next session, you can tell me right now. Otherwise, I will end this session and we will meet on next Friday. Anyone wants to say anything else? Notes link. You will, I think, get this notes link. I have to upload it somewhere, but you will be getting that presentation folder link. So I will upload the notes there only. Anjali, can you introduce yourself?
Hello, madam. I'm a PhD scholar doing PhD in Kerala Technological University from Kerala.
Okay, right. Because it was written assistant professor, no, in your name.
Yeah, I'm working as system browser.
Oh, fine. So the notes link will be uploaded and I think you will be getting it from the Neptel side only. I don't know how they will transfer it to you, but I have a folder created already. I will upload the notes there only.
Okay, thank you, ma'am. Thank you.
Okay. So should I end the meeting for everyone? Okay, so I'm ending the meeting. So see you in the next session.